Hello, everyone, and welcome to How to Build a Financial Analytics App Using OpenAI and Langchain. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a SingleStore webinar, heads up that we present weekly technical workshops demoing data and AI use cases and new technologies. In fact, next week, we will be presenting how to build a ChatGPT app using JSON data. During that time, our lead engineer, Jason Thursness, will be demoing how to build a sample recommendation engine off of JSON data using SingleStore's vector functions to power semantic search with OpenAI. SingleStore has a new MongoDB API feature that powers up to 1000x faster JSON analytics without any query changes or transformations. So if that sounds fun to you, register now. You see the link on the screen, bit.ly/ChatGPT JSON data webinar. I'll put this in the chat as well, or you can use that QR code that you see on the screen. And yeah, I'll put that in the chat in a minute. But back to today's topic. We have some fantastic technical experts that are also joining our Zoom Q&A. They have a good grasp of the technologies that are involved. They're ready to answer your questions interactively, so keep those questions coming throughout the session. Please welcome Akmal Chowdhury, Eric Hansen, and Jason Thursness. We'll try to get to as many of your questions as we can as they come in. I will also flag a few for the live Q&A at the end of the session. We'd love for you to try out today's technology. In fact, anyone who tries it today will be entered for a chance to win new branded AirPods Pro. Simply click this link that you see on your screen, bit.ly Financial Analytics Raffle. Hit that QR code that you see. I'll put these links in the chat as well. But if you log in through this link, you will be eligible. Free trial if you're a new user, existing account if you're already a customer, or if you have an ongoing trial. We will check out the folks who log into this link. We will announce a winner by the end of today's session. And I should mention, after today's webinar, everyone will receive an email with the recording, with the GitHub link, with the assets from David and Vijay's presentation. So let's introduce our speakers for today. First up, David Lee is a cloud solutions engineer at SingleStore. His job is to help SingleStore customers employ technical solutions to solve complex data problems. He has experience with data science, cloud architecture, and multiple types of machine learning and AI use cases. And then Vijay is a senior director of product marketing at SingleStore. He handles our product launches, technical marketing, GTM strategy, and more. He has over 18 years of experience in diverse IT areas, including big data analytics, database, AI, machine learning, IoT, managed services, and more. Welcome to both of our speakers and to our audiences. Vijay, I think you have the floor first.
Awesome. Thank you, Matt. And hello, everyone. Good morning, good afternoon. My name is Vijay Raja. I'm the Senior Director of Product Marketing here at SingleStore. I'm very excited to be here today with my colleague, David, to talk about building a financial analytics application using OpenAI and Langchain. So before we jump in, let's talk a little bit more about what we are going to be covering today. So today we'll go through an example of how to build a conversational AI financial application using your own data or using market data. We'll be showcasing how to speak to your application in plain English to get accurate responses using OpenAI. David also walk you through how to power vector and semantic search using simple SQL queries using SingleStore, and also how to drive blazing fast analytics on JSON data using SingleStore Kai, which we'll talk a little bit more about. Okay. So as I mentioned later today, David is going to help walk you through how we build this. But before we jump into the demo, wanted to spend some time going over the basics and provide you with some more context so that you can better appreciate what you're going to see today, especially for folks who are not that familiar with SingleStore. Okay, with that, let's jump in. So Gen AI is obviously all the rage today, and organizations are increasingly using this to power a number of compelling use cases, including everything from chatbots for live customer service or issue resolution, semantic search to power applications that not just looks at the data or the word itself, but looks at the intent and the context of your search, right? And we have seen a lot of activity around things like image search, image recognition, facial recognition, audio search, and more. In fact, one of our customers, Athon, is actually using SingleStore to do facial recognition and image matching in real time to help identify and find missing children and exploited children. So lots of activity happening in this space. But the challenge is, if you start to think about it, when you talk to customers, how are they trying to build some of these applications? It's very interesting. So if you look at customers today, they usually start with an open source database, such as a MySQL or a Postgres, and use that to power the application. Now they want to bring in some third-party data, maybe a JSON data, semi-structured data on JSON. Now, guess what? You need something like a MongoDB, right? Now, as your number of users grow, as the data complexity grows, your performance of the queries start to drip, and then you need something like a cache or a Redis. That gets added into the equation, right? Now you need to do some full text search. They add Elastic into the equation. You need to add Elastic. You need to bring in streaming data, IoT data, or clickstream data, real-time data. Now you need to make sure your database is integrated with Kafka, right? That's all on the operational side of things. Now, if you need to serve some analytics on your application, or you need to do some real-time analytics, guess what? You now need to add another set of analytical engines, be it, like the Druid, Snowflake, Rockset, ClickHouse, so on and so forth. So you get the point, right? And now we have an AI movement, right? So if I need to do AI or vector capabilities, you see customers going to a specialty vector database like a Pinecone or something else to kind of power the AI capabilities. As you can see, this is an incredibly complex and inefficient way to power your applications. You are stitching together all these multiple databases, data engines. You're moving data, you're replicating data, you're doing ETL. And guess what happens? It starts to impact the performance of your engine, of your applications. It starts to impact the customer experience, and you can't scale fast enough. You run into scalability bottlenecks. Your data in the application is not fresh. You're showing data from an hour ago, a day ago, half a day ago, so on and so forth. And most importantly, it's going to impact your cost as well. So there has to be a simpler way to build these kind of applications today, right? Welcome to SingleStore. SingleStore is a single unified database to transact, analyze, and contextualize data in real time. Okay, so what do I mean by that? In plain English, it's a distributed relational database that can do transactional, which is OLTP, and analytical, OLAP processing, together with vector capabilities in a single engine. Okay, so you might be wondering, okay, how do you do that? So let's dive a little deeper. So when it comes to transactions, as the transactional capabilities, SingleStore has an in-memory row store that can do extremely fast writes and fast record lookups. And more importantly, we are built as a distributed SQL database that's horizontally scalable. So you can obviously scale up and scale down depending on your needs, but as your business needs grows, as your data grows, you can scale out horizontally and add more nodes as you grow. And by the way, in terms of transactional capabilities, we obviously have enterprise features such as high availability, disaster recovery, point-in-time restore, all of that stuff, all of the fun stuff, right? So that's the transactional element. Now, when it comes to analytics, we also have a column store, or what we call universal storage, that is used to drive high-performance analytical queries or run large-scale aggregate functions. Okay, and when we do queries, we usually deliver millisecond latencies, and that's due to this unique combination of a row store and column store together with the cloud object store, right? All in a row store, column store, and a single engine is what gives you that power to drive super fast queries. Also keep in mind, the column store also gets you like 80 to 90% compression on your data to help keep your costs down. Okay. Now let's talk about the contextualized part, this is really the AI or vector capabilities that we're going to be focusing on today. Okay, so SingleStore has had vector capabilities since 2017, way before this Gen AI revolution got started. And we already have customers using this today to power things like semantic search, image recognition, so on and so forth. And something we also added on is notebooks, which you're going to see today that David is going to showcase a notebook today that allows you to run Python code along with SQL on top of the database. So it's very easy to power your applications using SQL and Python. Okay, so now that you have an idea of what SingleStore does, let's take a look at how does SingleStore fit in. So if you look at, one of the key attributes that SingleStore provides is a native functionality called pipelines. So think of pipelines. What it basically is, you can write 5 lines of SQL. You can now ingest high throughput streaming, parallel ingestion up to millions of events per second from distributed data sources such as Kafka, Amazon S3, Azure Blobs, HDFS, MongoDB, whatever, right? So you can ingest millions of events per second and have it immediately available for query, right? So you don't have to wait for ETL and whatnot. You can actually have it available for querying instantaneously. So that's the pipeline around data ingestion. But where do you run this? Practically, SingleStore runs pretty much everywhere in all of the leading clouds, including AWS, Google Cloud, Microsoft Azure, or your customers run it on premises as well, right? So it practically runs anywhere that you would want it to run. And, we are a relational database, which means you obviously process and store and analyze SQL or relational data, but it goes so much beyond that, right? So we support other data types, including things such as geospatial, full text search, JSON, vector capabilities, which we're going to talk a lot more today, time series data, so on and so forth. So you can practically ingest data in near real time from multiple sources and do processing and storage processing and analyze multiple different data types to really power applications or real-time analytics, or in a lot of cases, what we are seeing is applications with analytics, right? When you want to serve analytics within an application, or what we call in-app analytics, right? So this is where customers are using SingleStore to power different types of applications, including real-time applications and analytics to their end customers, okay? So we talked a little bit about multi-model capabilities. I want to kind of double-click a little bit more. So we mentioned relational because we are a relational database. Obviously, we support structured data, relational data, but we have multiple other data types, including unstructured data, semi-structured data, such as JSON. We also support time series data, especially for some of the IoT use cases or cybersecurity use cases. And another new function we added, obviously, is around vector capabilities, since that we're going to talk a little bit more about. For the purpose of today's webinar, I want to double click on 2 of these, which is the JSON capabilities and also the vector functions, because you're going to be seeing David utilize both of those data types and functions as part of the demo that you're going to be seeing today. Okay, so let's spend a little bit of time talking about JSON first. Okay, so SingleStore has had JSON capabilities for a number of years, and our customers extensively use SingleStore to process and analyze JSON data. In fact, it's probably one of the highest utilized data type beyond relational data, I would say. But what we launched recently is the interesting aspect. We launched something called SingleStore Kai about a month ago. And SingleStore Kai is basically an API for MongoDB. It's a MongoDB API that lets you drive lightning fast analytics on JSON data. Okay, so it's basically an API for MongoDB that lets you drive fast analytics. So you might be wondering, why do you need to do that? So if you think about MongoDB, it's a document database, right? It's a document database designed as an operational database. It's not designed to drive analytics or fast analytics on JSON. So if you have to do analytics, what customers end up doing was they have to extract data from MongoDB. They have to do transformations. They have to flatten the data and put it into an analytical engine, such as a Rockset, a Snowflake, or an Elastic, to try and do analytics. But guess what? That's not easy because you're obviously, flattening the data, you're transforming the data. You have to rewrite all of those MongoDB queries or the application to support now SQL queries that a analytical database can support, right? Leads to increased latencies, increased data movement, additional costs, costly infrastructure, so on and so forth, right? So what we introduced is SingleStore Kai. It's basically an API, MongoDB API that can drive up to 100x faster analytics on JSON data for your MongoDB applications. You're going to see David use Kai today to bring in data from MongoDB and do analytics on it, and we'll dive a little bit more on this. But here's the cool aspect, though. It's not just about driving 100x faster analytics on JSON. The best part is you can do this with no changes to your MongoDB queries. So you can use the same MongoDB queries and still drive 100x faster analytics. Just point the analytical queries to SingleStore, and you can drive up to 10 to 100x faster analytical queries on those on JSON. So no query changes, no application changes, no data transformations. And developers can continue to use the same MongoDB tools, drivers, and frameworks that they are familiar with. Okay. So we have done extensive benchmarks and testing on Kai capabilities, obviously. So what you see here is one of the tests that we ran, and there's a whole blog and a paper around this where you can see the extensive internal testing and the external benchmarks that were performed. So on this one, as you can see, this was an IoT data set. Some of the queries were like 800 times faster. So, queries, some of them were like 300x faster compared to MongoDB, and some of them were like 20x faster. So as you can see, between 10 to some of the queries were 1000x faster. On an average, you'll get like probably 100x faster performance on the same MongoDB queries. Okay. Now, so that's the JSON, part of the JSON capability that we'll be touching upon today as part of the demo. Now let's shift gears and talk a little bit about the vector capabilities that we talked about. Okay. So as you can imagine, Gen AI applications, it's all about vectors, right? So powering AI apps is really around, the vector functionality that you can provide. So it's all about how do you create vector embeddings, how do you store vector embeddings, and then how do you do search or analytics on these vector embeddings, okay? So for creating vectors, you can utilize APIs such as OpenAI embeddings or Hugging Face transformers, or a number of other tools or APIs that you can use to create these vector embeddings. Today, as part of the demo, we're going to use OpenAI, but you can use any of the foundational models or APIs, including open source LLMs or private LLMs for this. Okay, so that's the creating vector embeddings. But once you create these vector embeddings, you obviously need some place to store it, right? That's where a database comes in. It's database with vector functionality, right? And you can use indexes such as inverted index, B-tree index, HNSW, so on and so forth, to kind of store vectors. And finally, when it comes to searching the vectors, this is where you utilize algorithms or functions such as cosine similarity or Euclidean distance, and there are multiple other functions that you can use to determine how closely similar two vector embeddings are or how different they are. So you can use these algorithms like cosine similarity to figure out how closely related two specific vector embeddings are. Okay, and we'll go a lot over that. Actually, you can get to see that in a demo as well today. So, so what has happened lately is that there's a host of specialized vector databases that have emerged, including the likes of, you might have heard the names Pinecone, Milvis, VV8, Zills, ChromaDB, so on and so forth, right? However, keep in mind that these are specialty single-purpose databases. So if you think about that spaghetti chart that I showed earlier, this becomes yet another silo or a piece of the puzzle that you now have to solve for, that you now have to manage, that you now have to pay for, right? And keep in mind, there are some critical gaps when it comes to these specialty vector databases. So for example, number one, there's limited or no SQL support. So what that means is you have to write custom code or use custom languages that offer minimal flexibility, and analytical capabilities. So it really limits the applicability, especially for developers who are trying to build these applications, right? Number two, it's built only for vectors. They only support vectors, and there is minimal support for other data types, such as, let's say, SQL, relational data, JSON, time series data. And you cannot combine or utilize other data types, such as JSON or relational data, when you're trying to build your applications. They serve a very narrow swim lane of single-purpose databases. And that's another challenge, right? Another key aspect to keep in mind is that specialized vector databases are very compute intensive. They're memory intensive, compute intensive, and so expensive, and usually take long indexing times. And last but not the least, there are enterprise features such as things like ACID transactions, high availability, disaster recovery, point-in-time recovery. All of these are enterprise features that you would assume or want to have in a transactional database. But a lot of these emerging databases really lack those enterprise features, or leave a lot desired to be matured, right? Because these are new, and these functionalities take a lot of time to mature and really get good at. So there's a lot to want in those specific areas as well. Okay, so with that, so then what do you need in a database, right? So what you typically need for Gen AI applications is what we call a contextual database. What do you mean by a contextual database? You need to be able to work with all data relevant to the company, not just vector data. Because, obviously, when you're building an application, when you're building a recommendation engine or a chatbot, you want to utilize not just vector data, but all of your data. You want the ability to join vectors with other data, such as transactional data, analytical data, other data that's in other places within your repositories, right? You need the ability to connect and ingest data from multiple different sources and be able to analyze that data in near real time. More importantly, you need to have the ability to do hybrid search. What do I mean by hybrid search? Is that is really semantic search with full text search on the same data, right? And last but not the least, you need the ability to run it in the cloud or on premises. So SingleStore is really a contextual database that you can use to power your Gen AI applications. So it has support for not just vectors, but all types of data, including JSON, including relational, geospatial, time series, and more. And with SingleStore, you have the ability to join vectors with both transactional and analytical data using SQL. Okay. So for example, in the financial analytics space, you may want to look at, what impacted the stock price of that ticker based on trading volumes, based on their latest earnings data, maybe looking at news articles based on the, did the news articles have any impact on the price of that stock? Or maybe any competitive announcements that were happened during that time span, did that impact the stock price? So on and so forth, right? And using pipelines that I mentioned earlier, you can ingest data from diverse sources and do transformations on the fly. And more importantly, you can now do hybrid search, which means you can do vector search and full text search using the same data using built-in functions. So we use something called dot product capabilities. And so when you look at SingleStore's vector capabilities, as I mentioned, we have had vector capabilities since 2017, way before this Gen AI revolution. You're really co-locating the vector data with your enterprise data here, right? And then we have built-in functions such as dot product, that you can use for near-neighbor search, which you can use for doing semantic search on your vector data. And then we also have integrations with LLMs or platforms such as OpenAI, LangChain, and Llama Index. And I think I mentioned previously, like customers are already using this today to power, chatbots, to power semantic search, to do similarity matching, so on and so forth. Okay, so hopefully that gives you a good sense of, again, some of the challenges involved in building Gen AI applications. What SingleStore is, I think we went over what is SingleStore, just a brief overview of what SingleStore is and how that can help you. And we also went over two specific functional areas, which is how do you process and analyze JSON data using SingleStore Kai. And also we talked about vector capabilities. And the reason I mentioned all of this is because you're going to be seeing all of this when David is going to run through his demo on building this financial analytics application. Okay. With that backdrop, David, if you are ready, I'm going to pass this over to you so that you can actually really do the show and tell and show the audience on how we build this financial analytics application. So over to you, David.
Thank you very much, Vijay. You're going to have to stop share. Okay, there you go. I can share my screen now. Perfect. All right, so hello, I'm David Lee. I'm a cloud solutions engineer here at SingleStore, and I'll show you an app that I built using SingleStore, OpenAI, and Langchain. And the idea behind this is to be in the shoes of a financial analyst that needs to gain insights on company data in a frictionless way. Many companies are already going to have data somewhere. So in this example, we are going to have stock ticker data that's already stored in Mongo Atlas. So before I get started, let me actually show you how you could get started with a SingleStore trial. You could go over to the link that Matt is going to share in the chat, and that's going to take you to this page. And then there's a button to try SingleStore Kai. And when you sign up using this link, your cluster will be enabled with the SingleStore Kai feature. So you definitely want to sign up using this link, and plus it'll enable you to get in the raffle that Matt is doing as well. And once you've signed up, it'll bring you to the customer portal UI, which looks like this. And what we have here is our workspace groups. I already have a workspace set up right here. And these are going to be where your workspaces are going to be stored, as well as your databases. So all of this is set up. There's one other thing that I'll show you, that you could connect directly to your SingleStore cluster using any of these endpoints, whether it be a SQL endpoint, a BI tool like Tableau or Power BI. In this case, we're going to be using the MongoDB client. So that connection string will be outputted right here. So once that is set, I also want to show you that we have SingleStore Notebooks, which is a Jupyter Notebook environment. And that's where I'm going to be running this, this demonstration. So when I was building this, I was thinking about some of the pain points that users might experience with current Gen AI use cases like this, such as having your development team learn a new language. You know, maybe your team is very familiar with SQL or Mongo and they don't want to change. Then there's the overhead of another database, you know, and then the data movement that's involved with that. You know, there's the idea of between changing to different products for each of your different use cases or data types. And you ultimately have to write your queries, your analytical queries. So all of that takes time. You know, it'd be great to make an easier way to get sentiment on the data that's important to you. And I think SingleStore is well positioned to solve all of these, simplifying both the architecture and the user experience. So in this architecture, you can see on the bottom left that we have stock ticker data that's stored in Mongo Atlas that we're bringing to SingleStore using the SingleStore Kai API. We also have news article data that's going to be sent to the SingleStore notebooks, and we're going to get embeddings from these articles by splitting them up into smaller chunks. And then we're also going to output a prompt for each of these chunks that we're going to store into SingleStore. And then on the right, we have our chat UI, which is basically where we're going to ask our database questions on the data that's there. So first, I'd like to show you the UI that I built, and then we'll go over how we built this. So let me start this application up. And basically, I have this app that's connected to the SingleStore database. Let's actually start by asking it a few questions, and we'll be able to see a couple of background, all of the background steps that are happening on the terminal window on the right. So let's ask it a question. Describe the database. So that WAV file has been recorded in a file called recording.wav. And we can now see the background steps that's interacting with our database in OpenAI using Langchain, specifically the Langchain SQL database agent. And we can see the answer that the database contains two tables, an embeddings and stock table. And it also outputs the DDLs for each of these tables for the embeddings and stock table. And when you connect to your database using the SQL database agent, it already has some of the database schema already in the application. So it didn't need to output a query for this. Let's ask it another question. How many rows are in the stock table? All right, it's doing the same thing. Got the recording. It's taking a look at the agent executor. It sees that there's the stock table and the embeddings table. And because I'm asking something about stocks, it's going to look at the stock table. So we see the that DDL as well as some information on it. So it's learning about the data, and it's using zero-shot learning to basically output what types of queries it will need to do to get that answer. And we can see the answer that there are 6 million rows in the stock table. And it even outputs the SQL query, select count star from stock table, which is absolutely correct. Let's actually ask it next a more difficult question. That'd be more in line with what a financial analyst would ask. What date time had the highest price for Amazon stock? When was it, and what was the price? All right, it took a little longer to get that recording. It's transcribing that into text, sending it over to OpenAI, and we can see that it's thinking about which query it would make sense. It runs the query again to make sure that what it thinks is in fact the right answer, and we can see that the highest price for Amazon stock was $188 and change, and this was on 2021, July 13th at 10:35 a.m. At this time, it didn't output the query, but we could actually see the query in the agent chain right here. So let's actually take that query, and I'll show you something really cool with SingleStore notebooks here. So in SingleStore notebooks, there's a few things I want to point out. One is that we're connecting to our workspace on the left on our connections tab. And then we have our database on the right. So I am in fact connected to the correct database. And then we can turn any of these cells into a SQL cell with just this syntax. So what I'm going to do here is just paste that query and check to see that answer is in fact correct. And if it is, maybe that's a query that I want to store for future reference. And we can see here that this outputs the high of 188 and change, and as well as the same date that the app had outputted. So we can see that this does in fact match. So that's the app. We'll go back to it in a moment. But what I want to do is basically go over each piece and how I built this now. So we can see here, in the bottom left, we have the stock data that's going over to SingleStore using the SingleStore Kai API. So let's go ahead and take a look at this. And actually, as a quick reminder, as a quick note that I want to mention, I'm using OpenAI in this demo, but this could be any LLM, whether it's a private LLM, Hugging Face. You could kind of just drop and replace that and have this demo work. I just picked OpenAI because it's well recognized, it's easy for this demo. So just keep that in mind. So let's go over to step one, which is to bring the data from Mongo to SingleStore. And basically in my Mongo Atlas instance, I have the stock ticker data with some stock data like the close, the date, the high, low, open, and the volume. I'm using the PyMongo library and setting up my connections using the connection string. So earlier when I was showing you the workspace connection details for the MongoDB or for the Mongo connection, that connection string is over here. I include my password, and we're able to make the connection to SingleStore Kai. Okay, I have my Mongo database, which is called test, as well as the collection, which is called stock data updated, and as well as my SingleStore database AI demo and the table. And then I insert all of those records over to SingleStore just with an insert statement using the pandas data frame. And basically the end result is this table, the Mongo JSON. And what this is basically a randomly generated ID. And then each of the rows in the stock data collection that's outputted in the more column that you can see right here. The next thing that we do is we're going to test the analytical performance of Mongo versus SingleStore Kai. So again, using the same endpoints, I'm able to basically write out a couple of functions to run these queries and output the average response times for both of these queries. So it's going to output the query results for Mongo as well as SingleStore, and then it's going to output the response times. And the first thing that we're going to do is just count the number of records to make sure that the Mongo collection and SingleStore table rows match. And in fact, they do. Next, I want to show you the query comparisons where we're going to use that function we just built out. So for this first query, we're going to get the average price for specific tickers between two date ranges. So we can see the date ranges right here, 2020 in December 20, as well as 2021 in May 30th. And we're going to run this query for both of them. As you can see, this query one, we're not changing it. We just run this query, and we'll be able to get the answer in just a moment. Awesome. So the average price for the Amazon ticker for the Mongo was 161 and change. It's the same thing for SingleStore with 161 matching again. But here's the really neat thing. Using SingleStore Kai, we can see a dramatic increase in performance, whereas the Mongo query took 4.5 seconds and the SingleStore query was just over a second with a factor improvement of 3.7 times faster. Let's do another query where we're counting the records group by ticker. And these are, again, very simple queries and a very small data set. As you get higher amounts of data that you're running queries on and more complex queries, you could see that factor of 100x and sometimes even upwards to 1,000 when using the SingleStore Kai API. So we could see here that the counts of records for Amazon on Mongo was 2.4 million. For Microsoft, it's 2.6 million. I'm just going to move this chat window out of the way so it's easier to see. And then we have the Google records at 900,000. And those records are outputted in SingleStore, and they do in fact match. But here's the cool thing. The Mongo query took 4.5 seconds, whereas SingleStore took about half a second with a factor improvement of almost 11 times faster. I also want to actually bring up my terminal window because I set up basically a Mongo shell connection for both the MongoDB as well as SingleStore Kai, and I'd like to show that as well. So what we have here is on the left we have the Mongo connection, and I have a query that's going to get just the average high price for each of the tickers. And let's go ahead and just run these queries. And you could just notice the only change here was the database name, which, in the table name that I've set up. So let me run the Mongo query first, and then I'll run the SingleStore query. And take a look at that. The output for SingleStore was a lot faster than the Mongo connection. And we can just verify that the answers are correct. Amazon, the average high was 40. Average for Amazon on this one is also 40, and then we have 64 and 73. So those all match. So it's very flexible in how you want to interact with your database using the SingleStore Kai API. Awesome. And I ran that same query over here. We could see that in this case, it was almost a 13x improvement in speed. So that's the stock ticker data piece. All right. We brought the data into SingleStore using SingleStore Kai. Next, we're going to talk about bringing in news articles into SingleStore, chunking that data and getting embeddings for both each of those chunks and a prompt for each of those chunks as well. So let's go ahead and jump to this piece here. And in order to do this, what I've done is I've created an embeddings table. And basically, this is where I'm going to store my embeddings. In this case, the chunks of text are going to be inputted into the answer column, whereas the prompts are going to be in the question, and we're going to also bring in the embeddings here. What I've done here is just ran a few functions that is using some prompt engineering when these chunks go to OpenAI. For example, it's going to give it some context that you pretend that you're a financial analyst, and given the following text, which is each of those chunks, give me a prompt that would output this answer. So, and it will output some sort of question. So once we have that all done, we're using an API in this case, but you could use the request library, use any way you want to web scrape news article data that's relevant for you, and you could bring that data in using a script that's similar to this one here. So what happens after you get each of those sections is we just use the SQL Alchemy library, Python library, and we do an insert statement into the database. There is one thing that I want to point out, and that is our vector function, specifically the JSON array pack that we're going to pass to our vector embeddings. And we can see here that the example output here is we have the category, which is the company name, the question that's outputted after it's run through the OpenAI model, and then we have the vector embedding, which is going to be passed through the JSON array pack function. And basically, that's a helper function for vectors that takes on the JSON array of floating point numbers, and it returns a packed binary blob, which is very efficient for use in vector functions for SingleStore. Okay, the output is here's one row of just a chunk. We can see here that basically it takes the 1,000 token chunk that's split. In this case, it's an incomplete sentence. Markets of the world, watch how Amazon is shipping for third parties to compete with FedEx and UPS. And then I'm creating a prompt for that I could later search and do semantic similarity searches for in the question. So this is the question. What are the biggest e-commerce markets in the world, and how is Amazon shipping and third parties to compete with FedEx and UPS? So again, it's a pretty good question to get this sort of a piece of text that we can later pass to another inquiry to your LLM. So now that we have the news article now in SingleStore as well, I'm going to focus on the building of the chatbot and using LangChain, and later we can query the news articles and get some semantic similarity functions done using like the dot product and so forth. So in order to create the chatbot, I created another table called stock table. And basically, the reason I did this is we have a Mongo JSON table that we brought into SingleStore using the Kai API. But using LangChain's SQL database agent, it's basically looking at the table DDLs, and I want to help it to find the right columns to basically make the chatbot work. So that's what we've done here. We've added the stock table, and then we've inserted those rows into that stock table using this query here. We've already done that, and we can see that it outputs each of those tickers, as well as the other data that was in the JSON for each of those stock tickers. Okay, the next thing I'm going to do here is I'm going to add my OpenAI API key. So just give me a moment while I copy and paste this in. And once it's in, I'll be able to run OpenAI commands. And in this case, we're using LangChain. I already mentioned that we're using the SQL database agent. I won't go into too much detail here. You could review this after the webinar, but basically I enter my API key here, and then I give it the SingleStore host connection details right over here. And the rest is basically the prompt engineering I've done to give it a little bit of context about our database, as well as some functions for our database as well. There's also another piece here where I output the query for the final answer. And that's why in the app, we were able to see the SQL query that was outputted. So let's run this. Let's run this as well. But let me first go back and install these libraries. So this is just going to take about 20 seconds here. And once that is done, we'll be able to run that query again. So just give me one moment here. And when we run this next, we'll be able to see the execution time once that's done. So while that's running, I'll go ahead and go to the embeddings portion of this. So I have a few embeddings functions that I'm going to be passing to the text that I'm giving questions to, as well as the answers for the chatbot. And one of the things that happens on the chatbot is first, I input the question using voice recognition or just regular text. It gets an embedding for that, it stores that, and then it gets the answer, it gets the embedding for that, and then it sends all of those values, the questions, answers, the embeddings, as well as the time over to SingleStore using the SQL Alchemy library. So again, we have a very similar insert statement here where we do just that. So let's go ahead and create those functions. And basically we're set. We can now ask our database and use the SQL database agent to get answers for our questions. So this first question where we ask our database a question is how many distinct stock tickers are there and what are they? And immediately you're able to see that there are 3 stock tickers. I've got 20 years of intraday data for Amazon, Microsoft, and Google. And it outputs the query here for that as well. Over here, let's just run one more of these questions, and I'll actually go over to the chatbot. And now that this chatbot is done, I think it'd be really cool to see if we could use a question that filters the metadata as well as doing semantic similarity on that. So let's go ahead and bring this back up, and let's ask it this question. What are the 5 most similar questions for Amazon in the embeddings table? Okay, now that that recording is done, what's really unique with SingleStore is we're using SQL. So I don't need to get the blob data, the vector data for everything other than the Amazon category. So it's going to run the dot product function that I've taught it using the context in the prompt, and it's checking that, and it's outputting the records and even filtering based on metadata. So we can see here that there's a category equals Amazon, which is exactly what I want. Let's go ahead and read these results. You know, the 5 most similar questions for Amazon in the embeddings table are: what impact has Amazon's decision to curtail expenses had on air cargo demand? The next one is: what impact has Amazon's investment in air cargo had on the industry? So these 2 are very similar. But this one is a little bit difficult to read. So let me actually copy this SQL code and see if that works in the notebook here. Let's verify that that works using this syntax, and we'll just run that query. And again, we filtered based on the Amazon category in the embeddings table. We've outputted the similarity score using the dot product function in SingleStore, which is highly optimized, by the way. Just a point on our vector functions is they're built for very fast operations, and they use SIMD processing instructions. So that's why it's able to run very efficiently in SingleStore. But take a look at the results. These are very, very similar, and we have the scores. It's ordered in descending order, all within the SingleStore and the LangChain and OpenAI connection. So that was the chatbot that was built. The last piece that I've included in this notebook, which we'll share in a moment, is the UI piece. You know, how did I build the voice recognition and you know, get that connected with the UI? So I've actually created another file that I'm running in VS Code, but I've copied and pasted that code right in the notebook in this section here. And this is running on my local machine on my Mac here, whereas you know, the database is obviously in the AWS cloud in this case. So if you decide to give this a go, you'll have to make sure all of these libraries work on your local device, and then you could just copy and paste this code block, input your API key, update your credentials, and it should work. And basically for the UI, I've used a simple Python library called tkinter. I've added my audio libraries, you know, using PyAudio and Wave. I've used OpenAI's Whisper library, and then that was basically I was able to record my voice, get a recording WAV file, and then send it to OpenAI's Whisper model, which would transcribe that into text, which I then use for for the prompt for OpenAI to get the embeddings. And that's pretty much what I've done to build this demo. You could review the code that's going to be shared in the GitHub, and definitely feel free to ask us questions, but definitely start a SingleStore trial, give this a try, and I hope you enjoy this demo. So I'll send this back over to Matt.
Awesome. Thank you, David. We have way more questions than we could ever answer in 10 minutes, but I have tried to capture some of my favorites for the Q&A panel. Just a reminder to the audience, you can still get your questions in. That Q&A functionality is in the lower portion of your Zoom. Also a reminder, we're going to be emailing out this recording and the GitHub to everyone. So no need to ask about that. You will get that. So this first one is from Madhu. It's possibly a question for Vijay or maybe Akmal. Does the SingleStore Kai, is that available only with AWS cloud providers at this time? We use Azure for our programs, and we're trying to use the Kai feature.
Great question. So today, SingleStore Kai is available on AWS. You can, it's already available. You can try it out based on the link that was shared. It's not available on Azure yet, but we will be launching that pretty soon. So you can expect that probably in the next, I would say, next few months, we'll be probably launching one for Azure and eventually one for Google as well. So right now it's AWS, but Azure and Google are coming soon.
Awesome. Here is a question from Jose. It might be for Eric or maybe for David. It is, how do you handle this big amount of data? I mean, say we have a WhatsApp application. We want to store conversational data to later use for some analysis on types of answers or sentiment analysis or something like that. What would be the suggested way to store this data, as this could be very volume intensive?
Yeah, sure. I can take that one. SingleStore is a high performance, scalable database system. We can store tables with literally trillions of rows in a single table. So there's no problem of us handling the volume. You just create a table and insert your data in the table. And the table can have columns that are text, numbers, dates, date time, and vectors, and JSON, and other data types. So yeah, just use a table.
Awesome. Vijay, I'll give this one to you. Are there any documentation or evidence that discusses why SingleStore is so performant compared to other database solutions?
Absolutely. So I think that's a loaded question. There's a lot more documentation that we have white papers and blogs that really lay out what makes SingleStore unique and what makes these queries perform so fast. But the basics of this is, number one aspect is really the 3-tier architecture. So remember, we talked about there's an in-memory row store, there is a disk-based column store, and the third tier is really the cloud object store, right? So it is this combination of in-memory row store, column store, and cloud-based object store. And then we seamlessly are able to move data between these tiers based on the business needs, right? That's really one of the key attributes of what makes SingleStore really fast. And then obviously there are numerous other optimizations, including SIMD vectorization and so on and so forth, that adds to this. But we have blogs on this, we have documentation on this, we have, there are papers that have been published. So happy to share some of more details around what makes that SingleStore architecture uniquely specific. The other thing that I'll also add is, remember the pipelines, right? It's not just about not just about the query speeds, but keep in mind, you need to be able to bring in data fast and analyze some data as it lands, right? This is where that pipeline functionality comes to perspective, which is 5 lines of SQL can directly bring in data and analyze data as it lands without the need for doing complex transformations and stuff. Eric, do you want to add anything more to that beyond the 3-tier architecture and pipelines?
About what makes us fast? No, I think I'll pass on that now.
Cool. Here's another one. Bishal asks, and I'll give this to David Lee, since you built this. How do you verify that the code returned by the LLM is not malicious?
So there's obviously using something like OpenAI, it's using, basically data from the past in whatever context that you give it. So whatever it outputs, there are ways to basically check if it's accurate using other algorithms to do evaluations on that data. You could do other types of models and see if the answers are similar, run some sort of similarity searches on those. So there's other ways to just kind of check, and that would be a good practice to run evals on the outputs. But you know, a lot of in the LLM space, there's a lot of use cases for the outputs that these are, you know, that OpenAI returns, and even those are used for other training for other LLMs that are trained. So usually the results are going to be quite good, but you absolutely want to check using some evals.
Cool. Akmal, I'm going to give this one to you since I saw you answered it so nicely, but the audience could benefit from it. It's about kind of distinguishing, you know, the value of SingleStore. The question is, instead of using different zones in the classic data lake and transformation between those zones, raw, landing, clean, we can use SingleStore to access and store any type of data store in the database type: relational, vector, time series, structured versus non-structured, others. The abstraction is in the engine and not on the store.
Yeah, so that's a good question. And I think that it's one of the strong value propositions that we have as a company and as a product, that supporting all these capabilities, and they are kind of first class. They are not simply add-ons or simply layered, right? These are part of the core engine. These capabilities are built in. And it's a question of, you know, when do you need to use them? So with the vector functions, for example, as Vijay mentioned, we've had these since 2017. We've had customers using them now. Now it's become very important because of the interest in Gen AI, for example, as demonstrated by David in the demos that he's shown. So these are first-class capabilities, okay? They're supported by the engine. You may need some. Maybe you use all of them. That's great, you know, that's awesome. But it's not kind of a layer, or it's not something that's just an add-on. So it's very much part of the core offering that we have. And that's why we are called SingleStore.
And I'll just add to that answer that Akmal provided is also keep in mind, what we showed you is part of the standard SingleStore, like the base product, right? The standard edition that we have comes with Kai, comes with vector capabilities. It comes with transactions plus analytics in the same engine. So you're not paying for each additional functionality, right? What do we mention? It's all part of the standard base package, one standard pricing. So it makes it easy, efficient, fast as a developer or as an architect to put together these applications.
Good stuff. I think we might have time for one or two more before I announce the AirPods winner. Eric, I'll give this one to you. It was from Nasir. I'm not clear on how SingleStore will help me when I could just pass my data to an LLM model like Llama, which I could download on my local machine and get feedback on my queries about my data. So how will SingleStore be helpful if I'm building a custom LLM for my domain? And one other thing that I'll mention, Eric, is I know I've heard Madhukar speak about how, you know, there's B2C use cases and B2B use cases for LLMs. And he's talked about, you know, like buying a ChatGPT subscription as a consumer product for a single user, where SingleStore would be more of a B2B, multiple users, larger set of data, multiple data types, fine tuning. So anyways, I thought it was a great question. I wanted to give you a chance to answer for the audience.
Sure. So just to boil down the question is why do I need SingleStore? Why can't I just use my LLM to do everything, more or less?
You got it.
And so that's a really good question. If a good way to think about SingleStore, it's the long-term memory for your AI application. So you can get vector embeddings of things like text, you know, paragraphs or sentences from documents or text fields in your data, and add them to a database. And then you can do queries against that database using nearest neighbor search to find relevant information for your application. And then you might want to use that as context when you pass a question to your LLM question answering API, so it could give you a better answer.
Good stuff. I will wrap it up quick because we're at the top of the hour. Reminder, next week, we're doing that how to build a ChatGPT app on using JSON data. I'll put that link in the chat one more time. The announcement, today's AirPods winner goes to Mohan Anand, who is a senior technology manager at Thomson Reuters in Texas. So congrats. Thank you for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day. For anyone who tries out this GitHub, I'm going to put it in the chat right now so you can grab it. I will also email, hopefully I got that right. Yeah, I will also email it out to you in the next 1 or 2 hours with this video as soon as it's done processing. Thank you, Vijay, David, awesome presentation. Thank you, Akmal, Eric, Jason, for joining our Q&A team. Thanks to everyone. Have a great rest of your day.
Thank you all.
Bye-bye.